Yes, now you can start. The recording has started. Go ahead.
Okay, so you can see my presentation. You can see my screen.
Yeah.
Yes, Tejaswini, we are able to see.
Oh, all right. So yeah, let's get started. So first, what does when we say lead code, what comes to our mind is uh, it's a repo of different programs, coding, where a user authorized user can code for a given set of problems, submit his solution, and check if it is, the right answer. Can run different test cases, etc. So that is a core of lead code. But if you divide it into different things, these are the different functional requirements that we can think about when it comes to lead code. The first is here in this problem, I have assumed that it would not be an anonymous user who can run the code. So there is authentication and authorization that's required. So that will be one of the modules. Only an authorized user should be able to view questions, solve, submit, comment, upvote, and download. That is the first requirement. The second is with respect to the code editor. So this is where for a particular problem the user selects, IDE should be available, and the user should be able to type in his solution. There should be an input where the user can select the language. These are the few sets of language that needs to be supported. We can have many others. Uh, and then the user should be able to submit and run the solution and see whether it is right solution or not. This third part is the problem repository. This is where from the backend we'll have a list of problems being updated, and these list of problems will have different kinds of attributes that are associated with them. For example, what is the difficulty level of the program, whether it is easy, medium, difficulty. And this is something I found in LeetCode, where there are tags attached to which organization would actually ask these questions, the highest chances that these questions are being asked by these organizations. And then finally, there is a status attribute which says that whether this problem is already solved by any other user, or is it attempted and unsolved, or it is unsolved. So these are the different attributes that are associated with the problem, and that's another module of this big system. The next module is automatic grading. That is about running and seeing the output is right. And the lead code also provides, the information about how long the code took to run and what is the memory that it took to run your solution. What is the memory time efficiency and memory efficiency. And probably we can include a ranking also, that is at what level you are considering all the users who have submitted, how efficient your code is considering all the other users who have submitted the solution. um, there are additional features that the system has. uh, the first one is you can search problems. User must be able to search problems and also filter it based on. So if you go back here, this also the user should be able to filter the uh, filter the problem based on these attributes. This search of problems is basically, you enter the text and you should be able to search the particular problem. uh, Next one is solution repository. So as you have a problems repository, you need to have a solution repository as well. So solutions here, I have assumed that it can be of two types. It can be text or video based, or it can be both. So the solution provided can be text, video, or both. And also I have assumed here that each solution will have like 3 approaches per question. One is brute force, and the other two are need not be time and space, but more efficient approaches. And the additional peripheral systems that we. Yes. Yeah, someone had a question, I think.
Yeah, I just wanted to ask, like, is it
Hello. Actually, I'm not able to hear your voice. Am I the only one?
Oh, no, the problem persists with us also, Tejaswini. Your voice is breaking.
My voice is breaking?
No.
Janvi, can you repeat your question, or if you can type in chat? Yeah, just try repeating first. If we are able to understand, then we will proceed. Otherwise, type in the chat message.
Can you hear me? I
Yes,
think I
yes,
lost.
better. Go ahead.
Yes, Janvi, we are not able to hear you. Yeah. Now.
Yeah, can you hear me?
Yes, now I can hear you.
Okay. Just wanted to check, like, are there any test cases that will run when we submit the solution? Like when we say solution repository, the solution repository contains the test cases for the solution we give. Otherwise, yeah.
Okay. Yeah, that is a good question. Yes. So it will be like solution, and then each solution, there is detailed information later, but yeah, against each solution you will be having the test case IDs, test case associated with that particular solution that needs to be run. That's right. So there can be multiple test cases. So we will have that list also mentioned in the solution repository when we design it.
Thanks, Tejaswini. Sorry, I think my network is somehow not proper. Thank you.
No problem. Now it's fine. Thanks, Jan. All
Any
right.
other
So
questions
the other
from-
peripherals are, yes. Was there?
No, I was just
Another
asking
question?
others that in case any other questions or anyone wants to add anything on the functional requirement part.
Yes.
Go ahead. Yeah.
Okay. So in addition to this, we have like performance statistics and progress tracker that we can track. We can add badges and certification of completion for each user. Then discussion forum is another module where users can comment on the solutions. They can share solutions, uh, and discuss about solution, and can build a community of like-minded individuals. And then finally, recommendation service based on your performance, based on the user's performance, and the other data. We can have a personalized recommendation for practice problems, learning resources, and coaching. So, has everyone got an idea of?
Sorry to interrupt. There's a question I have related to the discussion forum. In discussion forum, whether the person can select whether he can have a discussion with any expert on the approach he has taken to solve the problem, or it is a discussion within the teams, or how it can be done.
Okay, that's a good question. I think here what I have assumed is that the discussion is between various users, And expert also can be a user, but it'll be like a admin user kind of a thing, expert user. But what I have assumed is once you are an authorized user, you should be able to comment on it. But there is no special feature. Maybe that can be a other concern.
Basic discussion among the user to simplify it.
Yeah.
Okay.
Yes.
Yeah, so here, Shivam, the discussion is based on the solution. So here, for any of the problem in LeetCode, you can go to the solutions tab and discuss various approaches to solve the problem. So maybe someone can submit some solution, their insights into the problem. They can ask clarifications about the problem, or they can share their solution and its description, its explanation, and share with the peer community, and others can view it, like it, upvote it, and discuss. So it's kind of a discussion forum per problem on the solutions.
Okay. Okay. Thanks, Tarun.
Okay. Any other questions before we move on to the non-functional requirements? Okay, so I'll assume we have some idea there. Now moving on to the non-functional requirements, these are few assumptions that I have made. We have 10 million total active users um, and 2 million daily active users. So among these 2 million daily active users, um, there is a division of what kind of users we have. We would have, most of the users who are viewing the problem, viewing the solution, and I'm assuming that we have like 1/4 of these uh, users actually submitting the writing the solution and submitting it. So when it comes to problem viewing, we have a read heavy system for the problem subsystem, and for the solution subsystem, it is a write heavy system. Now, based on these 2 million daily active users, I'm assuming that we will have at a time like 5,000 code runs per second. And, this is quite a huge number of submissions per second. It would be distributed across the day for different geography. And the latency here is a little interesting. So we are considering here 1 to 2 seconds of latency because this latency is with respect to the write, that is submission of the code. So when you submit the code has to run against n number of test cases depending on the problem, and then it should calculate various parameters and return. So latency of around 1 to 2 seconds is a reasonable latency. That is what I have assumed for code submission and run. The whole system, next moving to reliability, we will have a distributed architecture with redundancy and making sure that it should be fault tolerant, and any code submitted or problem submitted is always available in the system and is not lost. That is another requirement. And finally, coming on to availability, it's a 4.9 availability that we have assumed because 4.9 is 1 hour of downtime per year. So that is reasonable. And, that downtime could be, for some upgrade or any housekeeping that we have to do. And increasing the availability would increase our cost also. And since here we have a little, it's not critical, it's not affecting our business, 99.9% availability looks decent. Yeah, so this is about non-functional requirements. Any questions here? Okay, I'll move on to the back of the envelope calculations. I'll start with, problem repository. How much of data would we be storing in the repository? Here I have considered, assumed that there will be 10 new questions per day. 10 new questions per day. So if I consider it for a year and that value multiplied by 5 years, these are the number of questions that would be that we would generate in 5 years. And say one question is 100 bytes. I'm just considering the text part here. So that is coming around 2 MB of data. Here I considered document database because of the reason that this data is not transactional. I mean, we are not doing any transaction on this. So that's why I consider document database, and most of the time we are querying the locality of a reference will help us. For example, we will have maybe we'll have problem ID, problem text, and solution ID, and other things. So it's better we query the whole set, all the attributes. It becomes easier for us. Locality of reference of these attributes will help us. So that's why I have chosen document database.
Oh, Tejaswini, your screen share has stopped.
Oh, is it? Now is it visible?
Yeah, Tejaswini, now it is visible.
Okay. Anyone has any other thoughts on this? What kind of database? Or also here the size of the data is just 2 MB. That's why I could have gone for an SQL, but just for the reason that our locality of reference, I mean, we can pull out we need not do transactional query. That's the reason I opted for a document database.
Tejaswini, I have a question related to the document database. In this database, you are only going to save the problem details, right? Not the solution to the problem, no? Or how it is?
So there'll be, so I will be storing the reference of the solution in this table. So we will have like a different table to point out the exact solution, because solution repository will again have many other things like video solution, text solution. For example, this will have solution ID, and so these here we will have like solution IDs.
Okay.
ID.
The problem result, there will be a solution ID. It is like a foreign key.
Yeah, foreign.
Okay. And there is a limit for the number of solution also, no? Or it can be like 3 or 5 or something like that, or how it is.
So I have assumed like 3 is the maximum here.
Okay.
I will, because this is the solution that we like the problem creator will be giving, not the user.
Oh.
So yeah.
So document databases will have foreign keys. I'm not aware of. I haven't used them before. Is it a NoSQL, right? Are there any SQL databases also which are document databases? Any idea?
So I think the latest document database do provide some kind of query and foreign query also, foreign keys also, but it is not the conventional way. You are right. Like that is a good point. Tarun, you have any idea on this? Because I have read that they do provide, but I'm not sure if that is a good practice.
Yeah. So in MongoDB, there is no concept of foreign key. Foreign key is usually in the document database. But yes, you can have sub documents because you have JSON like documents, and the documents could be nested, and you can have relationship between the documents which are typically modeled using the references or embedded documentation, right? So it is you represent one-on-one relationship or one-to-many relationship between data entities using embedded documents in any NoSQL document database like MongoDB.
Yeah, I think that makes sense, Tarun.
Correct. But yes, you don't have exactly foreign keys because there's no concept of columns, and no, but you have the references which are kind of pointer to the other documents. They are used. This is the mechanism for modeling relationships between data. So it serves the similar purpose.
Okay, so is it like we can provide, suppose like this child JSON here, we can provide a link to the child JSON?
Yeah, right.
So,
So
or you embed, right, Tarun? As you said, you embed the entire child.
correct. Yes.
Like I worked with Elasticsearch in that you basically embed, you put like a
Yes,
list of calls. Yeah.
yes. So the way it works, let me give an example. So assume you have a database of books and authors. So you will have object IDs, right? So you'll have title, you will have maybe other details like date of publishing, and in the author ID field, you do not have to put the entire document. You can refer it to with the object ID. So object ID is probably I'll paste this code. I will give an example over the chat. Watch there. So you have this structure. Assume this is some structure, and this is your author structure, right? So you see here, this is how the references works, right? So first one is the posts, first JSON document. Second one I pasted twice by mistake, but yeah, first JSON document, if you see, is the uh, post, other one is the author. So you see that 6023 something like this is the object ID which is being referenced in the first document. So this is how you model foreign key relationships in NoSQL databases.
Okay. Yeah.
So this object ID, it can be from an object in a different JSON file. It will not be in the same.
Yes. So yeah, if just first JSON, the first curly braces, this is the different document, and the second one is a different document, right? So yes, no, this is
So,
good
so
clarification
Tarun,
that, yeah, go ahead.
to simplify this, no, there will be two JSON, one for the problem and one for the solution, and we will map it between them. Yeah.
Yes,
Yeah, yes.
absolutely, right? Correct. And there could be multiple, there could be one to many mapping, because the same object ID, if you use for, no, say for example, if you have a problem and then maybe you can have a array of solutions, right? If you want to preserve
Okay.
three solutions in this case, then you can have three object IDs, right? Solutions for 1, 2, 3, for all the solutions.
Okay, got it.
Okay, and yeah, similarly for solution repository, this is a calculation. This is the size of the text that I've assumed 20K is from the previous calculation that we did, the number of questions that we had. So this is the number of questions, and this is the number of solutions per question. So again, this comes 120 MB, and if you similar calculation for a video solution comes up to 120 GB. So we can use a blob storage to store these video and text solutions, and then we can use a document database to store the solution, uh, to store the metadata of the solution. So initially in our scale,
Sorry to interrupt. What is this blob storage?
okay, so blob storage is basically like you can store. It's like a file storage. It's like direct text and video. Is what you can.
Like a folder or something like that, or
It's like direct object storage. There is no. There are no tables and columns, so you can store the videos there, and you can get the link. It's more like the file system storage. Yeah.
So this is related to the video. What about the text? How will be? It is like a text file. Will be saving that. Is my understanding
Yes.
correct?
The whole text file is also. I'm also saving it in a blob storage.
Okay.
It's like a file storage.
Okay, thanks. Yeah. Blob storage.
Yeah, to just further clarify
so-
it, I will just share. Blob storage means this is object storage. It stands for binary large objects. Binary large objects could be text files or images, videos, documents like Word document, PPT. So it is used for backups, or you have some logs you can store there. And generally various cloud services like Amazon web services, they provide blob storage. Microsoft Azure also has a blob storage, and GCP also. And these are generally used for storing unstructured data and in binary format. It could be images, videos, documents. And yes, you can always connect with them through various protocols like HTTPS, or there could be SDKs through which you can connect and browse these blob storage and retrieve what you stored.
Okay.
And
Yeah.
yes, this is similar to we have a storage like Google Docs is one storage, but blob storage is more cheaper because no, here you don't get that features of accessing documents, sharing, collaborating. It is for storing raw data and doing data transfers, which is generally done for applications.
Okay.
Yeah.
So solution repository might have like this attribute. So instead of storing the exact text, we can store the link for the Bob storage.
Okay.
A link for the. Yeah. Okay, so in the non-functional requirements, we assume that 5,000 code runs per second would be there, and so if you consider that any server, if you consider 3,000 can handle 3,000 runs per second, then minimum we can have like two servers, application servers, and for replication and redundancy, we can have a replication factor of 3, which is basically each server has 2 more servers which replication is done, so that we don't lose data. It's reliable and also available. So total we can have like 6 servers. Now, how do we divide the workload between these two servers? That is where sharding and distributing load comes into picture. We have like two options here, by user ID or by problem ID. But user ID, so there is this distribution, right? Maybe we can do using the alphabets, in which the user ID you can actually, if we consider this user ID as numerical, then we can have a range of users being sent to the first server and the next range to the other server. But the downside of this is we might create some hotspots here, because we don't know, some users might be really active. Maybe for some reason, all the users in this set, if they are active, then we'll be creating a hotspot here, and if this will be, lightly loaded. That is one downside of this. Similarly, downside with the problem ID. If you say, partition or shard using the problem ID, then some problems might be really, there are a lot of people solving the problem ID. Then a similar situation can occur, uh, like a hotspot. So the other approach is consistent hashing. So here we can hash the user ID, and then uh, have a consistent hash algorithm that will actually assign this hash to a particular set of hash, and each hash set is mapped to the particular server. So in this way, if there is a lot of load in this server, we can partition the hash set and assign that or merge it with another server, and distribute the load to this server. So all that becomes very dynamic and easy with consistent hashing. So here, based on, maybe there is a hackathon or something that is hosted. So in such peak events, consistent hashing would come into hand. So that is why here I'm more inclined towards going with consistent hashing.
Okay. Tejaswini, I have a question here. See, for the first point, what you told in this particular slide, you told two servers will be the binary, and there will be a replication of factor of 3. So how you arrive to this two factor? What are the parameters you consider for this thing?
Okay. So generally, the standard replication factor to start with for any system is 3. So the logic behind that, what I remember is, so this is our main server, say, and this is two other servers. So say if you go less than 3, right? This is the minimum actually. So if you go less than 3, say this server is not at only 2. So you're running on only 2 servers. So if this fails, you have only one server left, so you need to connect to this server, the other server. But it is a very risky situation. So this server might take a lot of time to come up. It might come up faster, or doesn't come up. So here we are depending on only one server. To avoid such situation, we are having one more server as backup. So when this server goes down, say we have connected here, we have this as a backup. This is the worst case. We can have more, but it's according to I would say theory, our replication factor of 3 is a minimum for any system to be available.
The replication is for the database, no? Here we are talking about.
Yes, replication factor would be mainly for the database.
So when we say that the replication factor should be 3, are we saying that we want to maintain 3 copies of the data?
Correct. Yes, that's right.
And I mean, what is generally the logic or the concept that we use to determine the RF?
So there are many factors. One is, geography, and it depends on the load. I mean, how many calls you're getting. So there can be two things. One is, there are multiple factors. This can be your write replica. This can be your read replica. To distribute load between write and read, you can have reads going only to this and writes going only to this. But here, this is mainly for backup and restore. What I'm considering here. So RF3 is a minimum number for keeping a backup copy of the data.
Okay, this. My next question is: first, you came,
Just
you have
Shivam,
calculated for 2 servers, no?
just Shivam,
The
hold
first
on.
one.
Yeah.
How you came to the assumption that the 2 servers required based on this load?
So we have initially we assume that per second 5,000 code runs will be there, right? So yeah. So for any machine, for handle 3,000 requests per second.
So
That is what.
that depends on the configuration of the particular system.
Yeah, yeah. I'm just saying a commodity server, any commodity server would be able. So there are I think around 60,000 threads that can run on a server. So if you consider, I'm considering the least actually. If I consider I'm just considering 3,000 because the rest would be for applications, maybe system threads and all others, and some buffer to handle the peak load also. Like suddenly there is peak load, maybe we can go up to like 4,000 or 5,000 calls here. We can manage until we get get other server.
Okay. Basically, you took the 3,000 as the benchmark for each.
Yeah.
Yeah, got it. Thanks, Tejas.
I have some more input about the replication factor, why it is considered 3 as the minimal. See, replication is used for fault tolerance and high availability. And we have discussed this in our previous sessions with Manoj also, that there are various quorum based algorithms for determining whether there is correct data or not, right? So for example, in case of any system failures, the majority based quorum could be used. In case of 3, if you use 2, then what if the two sources have different data? Which one would you trust, right? If you have 3 replications, you find out in 2 replications if the data is same, you choose the one copy which is common across 2 data, which is the 2 sources, which is the majority. So this is the reason why you need 3 replication, and 3 replication, as Tejashwini said, is the minimum requirement for ensuring high availability and fault tolerance in distributed system.
Okay.
Right?
Got that. Thank you for the input. I just have a follow-up question on that. So when we say that replication factor is supposed to be 3, now we are speaking of LeetCode, so it makes sense that there could be like different versions. Say for example, for an application like Netflix, would there still be a replication factor of 3? Because in that case, there's A, too much content, and B, there is not much about updated content, right? Like in, say, for example,
Yeah.
for LeetCode, I'm working on any problem and I have made multiple submissions. So maybe one server has submission number 101 and another server has submission number 102. But in case of a content rendering kind of a service like Netflix or Hotstar, will it still make sense to consider replication factor as 3?
Right. Anyone want to take up this or this? Anyone would like to answer?
So I think that in terms of even in when we are storing these video content, a replication factor of 3 uh, does make sense. But there are because we cannot afford to lose data, right? Anyway, we have to be a highly reliable system. So a 3 is a minimum. In terms of storage, yes, huge data storage will be there, and I think we'll have to do some kind of chunk based storage and archive minimum, because otherwise, if one of the server is down, then we are at a very high risk situation if it's less than 3.
I got that point, Tejaswini. Tarun, I just had one question here. So, do we consider something like a cap theorem here, where we say that, in consistency, availability, and performance, we got to pick any two based on what the functional requirement of the application is? So, say
Yes.
for example, we are speaking of lead code. We will probably choose consistency to be there for sure because you don't want to see any old or wrong submissions. But in case of a streaming application, maybe consistency is not something that you will want to include. Maybe availability is what you will want to have higher focus on. So in that case, does the RF change in any way?
Correct. See, in case of Netflix, this is a totally different kind of system than lead code. In
Correct.
Netflix, you will be accessing the system from various locations. Say, for example, if any movie is there, you would like to access it from any remote place, and you want very good video quality as well as good performance, smooth viewing experience, because you don't want buffering, right? And there is a lot of network bandwidth which you will be consuming, which is not the case in case of lead code. So in
Correct.
case of Netflix, the CDN is a very important component. So
Makes
if
sense.
you are a production house, you will upload a movie or a TV show, and that TV show should always be available, because maybe you have invested crores of rupees. Say, for example, if you are a producer for some movie, like a big movie like Pathan, and you want to upload it to Netflix, you would want this movie to be there for many months, and it should not happen that some system crashes, or there is some earthquake, or there is some war somewhere, and you lose the movie and audience is unable to see that movie. So you will use the replication factor at least 3. But then when you are broadcasting it, now the movie is released, you would like people to access it from all across the world, right? Maybe even people in Sri Lanka, Andaman Nicobar, or remote places, maybe in some villages also, they would want to see it, and their experience should also be fast. And irrespective of what kind of devices they are and what kind of network they are, you want to give them good experience. So you will replicate this into various edge servers which will be located all across the world. So you will have hundreds of replication based on the regions. This way, when people are accessing the movie, because of less delay in the network, they'll be able to see good experience of movie watching, right? So they'll able to get that. And this is how it is done in Netflix using CDN. But here you may use CDN for some static content, but yes, it's
Hmm.
not that no critical here, because you don't transfer that much of data. And yes, you have some video storage as well, but yes, some strategy, similar strategy could be adopted, but the rigorousness will be much less than what is done in Netflix.
Got that. So, like as a rule of thumb, can we safely assume that for most applications, we should have a replication factor of 3? I mean, the need, like you said, we could use CDNs in in case of streaming, and probably that's not as applicable in something like LeetCode. But then having an RF of 3 for all applications is considered like a good thing to have.
Yes, as I said, when you have three replications, you will get the updates in one replica, right? But then how would you will have some lag. You will be reading and writing from multiple replicas, and maybe one is your master where you are updating, and others are the system where you would be replicating, and there would be some replication lag. So we had a detailed session on replication lag earlier, and we'll be having it going forward also. But in this case, if there are two replicas which are out of sync, then which one to trust is based on the majority, and which can only happen in case you have three replicas. So if you see the same data in two systems, then you can very comfortably see that this is the trusted one and right, correct, consistent data, and and you go with the majority. So that is the algorithm, which is quorum based algorithm for determining which data to be read and what to be displayed to the user.
Got it, Tarun. I'll go ahead and take a look at the previous ones as well. Thank you.
Yes.
I think I took a lot of time, Tejaswini. I'm sorry about that.
No problem. All good questions.
Sorry, Tarun, I have one follow-up question to
Great.
this.
Yeah, don't worry
See,
about the time, because
Yeah.
learning is more important, and we can
Yeah.
split the sessions also. So you should get each and every concept very clearly understood, because that is what is required to clear any system design interview. So please feel free to ask questions.
Yeah, my question is related to the Netflix. What you gave an insight. No? There are two parts you told. One is the three servers for the RF thing, and the
Yes.
second part is the edge server that is
Yes.
across the
Correct.
world. So my understanding is in the edge server you will have the video. For example, let us
Yes.
take the
Yes.
case of
Absolutely.
Pathal. No, you will have the videos in all these edge servers.
Yes.
In this RF servers, no, what data you will have? You will have the reference to this
Yes.
CDN or what data you will
Correct.
have?
Yes. Do not worry too much about Netflix or Hotstar. I will have a separate session on that. I'll plan that. But yes, to give you the answer in brief, in Netflix, you will have the raw data, which will be stored and which will be uploaded by any production house. And that raw data will be chunked, as Tejashwini said, and will be available in different resolutions for different devices. So you will replicate
Okay.
the for end users on CDN the processed videos, but the raw video you will keep a backup in case no you need to right regenerate more content, or right. So there is different requirements for production houses and for consumers. In case of Netflix, we'll discuss this in another session. I'll give a complete session because I gave a master class few weeks back for
Okay.
Scalar Academy also, so I can kind of give another session on that. I have the content I'll share. I'm looking to do that session with this group in coming few days.
Okay.
Sure.
Thanks. Yeah. Thanks, Tejaswini.
Uh, these are some additional considerations that we can take when we are designing a system. The first one is like availability zones. We can have three availability zones that we can consider. Maybe one in Asia, Europe, and US, where we can have a server, so that we can make our system more reliable and available. The next consideration is backup and recover strategy. This is like a leaderless replication. That is what we discussed here. That is what Tarun also mentioned, where we can have a quorum on how many servers have read the majority of data and decide which data to pick. So start. And here I have considered for most of the system eventual consistency, but one specific part, like when the solution, the test cases are updated, that part would be like we would require a strong consistency, because we don't want few of the users to validate. I mean, if you have like T1 to T100, and then the output of this, you know, a matching will be done for each of the submissions. So we don't want to have certain users use the old test case value and certain users use a new test case value. So that is the only place I feel that we need to have a strong consistency. Rest of the system, like updating the problem, uh, can be eventual consistency.
And just one more minute. So I have not yet fully answered Natasha's question about the cap theorem, because we should also consider the cap theorem here. So yeah, if you can give some inputs, Tejashwini, on what would be the cap theorem application here.
Yes, so we have cap theorem which says, either a system can be CP or it can be AP. So essentially what it means that, say you have again 3 RF replication model, and say there is a partition, network is drawn on, partition is created. Now in a consistent model, uh, we would, you know uh, uh, if we want consistency, if that is the that is how our system should be, then our systems, whatever read happens, wouldn't go through the system. The read would be, you can say it is like Blob. So all the servers are at the same state, so there is consistency in the system. Now, if you want the system to be highly available, there can be they can be eventually consistent, or we can manage with some kind of discrepancy in the data that we have. Then what we do is we go ahead and update the data. Probably these two machines will be in a different state where it is updated, and this might be in the old state which is not updated. But these data being available, uh, that is more important. So for example, upvote, we consider upvote, downvote, etc. These can be like eventually consistent, that is highly available. And for the solution we can go with CP, and that is strong consistency.
Great.
Does that explain?
Sure, go ahead. Yeah.
Sorry to interrupt. I had just one more question over here. So generally, whatever reading I've done up till now, we design the CP or the AP at the app level, right? Is it fair to do it in a way where we say that, this part of the system, like say for example the solutions, it should be CP, and say for example, other things could be AP. Like, does cap theorem apply at parts of the application also?
I think it should be flexible in those terms, provided based on our architecture. If we are depends on how we store data, and I have a modular kind of approach. Like if you have, as I said, like for my test data, I have a different database. So there, for me, it becomes more for CP to be applied. And for my problem database, since it's different, that AP would apply there.
Yeah, on different parts of the system, different considerations will be valid. So you have to apply cap theorem at different microservices level, or if your system is modular, you have to see what part is requiring what kind of capabilities. So yes, you have to apply it in parts, not as a whole.
Not at the high level.
Yes, yes, because the design
Got
will
it.
vary. You have
Makes sense,
right,
yes.
so different kind of databases, heterogeneous environments, and you can apply at different level cap theorem.
And that makes it easier for the person who's designing also, right?
Yes,
Because it you cannot have blanket rule for all microservices.
yes, yes, absolutely.
Thank you.
Okay, all right, moving forward. Uh, Now we will discuss about what kind of application architecture we want to do. I have chosen here microservice as compared to monolithic for the reason that this is we know the scale of the system. It's huge system. With microservices, it's easy to scale horizontally. We can have our probably use a Kubernetes containerized architecture with Dockers to bring up our different microservices and have them communicate with each other. So it becomes easy to maintain, and fault isolation also becomes easier because we can identify what are the microservices that are down and probably respin that or debug that, etc. So yeah, it simplifies the deployment. It's fast, and that's why I'm going with the microservice architecture. We as we saw that we had different modules of the microservice architecture. I will be focusing on particularly two which are like the heart of this. One is problem set and user solution set. That will be the modules that I'll focus on. But apart from that, these we have this authentication service where these are the list of operations that would be doing, creating users, login, logout, update profile, etc. Uh, and then this is another service search service. This is about creating secondary indexes based on the data that we have uploaded in the problem, updating the secondary index. These are all sub services, and then the actual searching of the problem. Now coming on to, yes, so this is our main service that we have to will design in a little more depth. So we'll have to build microservices to display the problem set, filter the problem set, get attributes of a particular problem set, update, mark the problem set as solved, attempted, or solution. I think add problem set is something I missed. Set. Uh, yeah. So these are the different list of services that we would need, and corresponding we'll have to define the APIs that would provide these functionalities.
Tejaswi, maybe I'm trying to, maybe you already have that in your following slides, but just curiosity that how these different set of like C, C++, or Python, Java, different solutions will be run. I mean, each will have a different microservice where one will be for Python. How is that? I mean, how is it going to basically execute the program and then come up with the results? Results in the sense whether it has passed, whether how much time it has taken.
Yes. So we have a detailed later discussion. We will discuss on how we are submitting, how we will evaluate, and how we will, decide, which language is selected, etc. But
I will wait for your explanation.
but for the crux of it, it will be like we'll have like Docker instances which will have the environment for a particular language, and we will route the request to that particular router, Docker, and then run, compile and run. So that is a brief answer for your question, but we will discuss in depth later.
Sure, thanks.
Yeah, for the problem repository, these are few of the APIs that I could think of. The one is get problem set, uh, user ID, level tags, status. This is just for authentication purpose. So we'll have a paginated result where it will give you a list of problem set. So here actually I've considered filtering the problem set also will call the same API, where we'll be specifying the particular filtered level tags and status that you want. If you want, these are like sub APIs where you want to get a status of a particular problem, attribute of a particular problem. This is actually adding the problem. This is adding the solution. These are a few of the APIs. Any questions here? Is my screen sharing?
Not suggestion.
Okay.
Not
I think my laptop like locks the sharing goes. Sharing.
Okay.
Okay. Moving on, what kind of this will be the attributes in our database. This is the schema of our database, how it will look. We'll have a problem ID, problem description, level, whatever we discussed, level, status, and tag. This is user ID basically who had submitted the problem. And this is like solution ID. This is basically solution IDs. It should be solution IDs because we have like 3 solution set.
Just a question, like, how the LeetCode sort of websites decide whether the solution is good performance, it's giving good performance. What is the, big O notation for the, solution? Is it based on the time that it takes? Or because analyzing each and every line and looking at for loops, just thinking it will be too much, right?
Yes, I think O of N for the, I think what I can think of is like for a large set of N, what is O of N, what is the time consumed and memory consumption, that is how they figure out. They'll give like huge input set and see if it is like N square, or N, maybe they have like that. We can have like that kind of a table for each of the solutions and do some matching.
Is it possible that, say suppose there is a less load on the system and the program gets executed pretty fast, though the performance is not up to the mark, somehow it gets passed? I'm just asking. Sometimes I have this question in my mind when I'm submitting my answers. So sometimes I feel that is it really optimal performance? Sometimes it takes, even for a very small solution, it takes long time to execute. Could be the load problem.
Okay. Yeah, I think what they might be doing is like again best of three. They might run in different servers. One is that solution, take the best case or the average case for your problem, and then tell you what is the OFN for your program. There might have like a backend monitoring system also for different servers. Like, are they running at their peak load? Is the load on these servers fine? If there is, if there is, say, this server is like highly loaded, then they might not send your code to run on this. They might send it on some other server. And but I'm sure they would do some. I think this is a very good question, but yeah, there would be. I can think of these two mechanisms in which we could handle, avoiding false execution times or false optimal execution of a program.
Yeah, yeah, makes sense. Yeah. Thanks, Tejaswini. Yeah, if I find anything, I will share with the team.
Yeah, sure. Okay. So the next slide is a little contradicting. I think I had confusion in the beginning whether to do. I think we spoke in the beginning that is no SQL. We'll go with no SQL, but here I have written SQL. That's because querying the problem for these will be easier, and the data which we calculated also was not huge. So I think I would like to ask the class what is a better option, NoSQL or an SQL?
See, Tejaswini, but in your previous slide, you were talking about the document-based database, no?
Yes, that's what I'm saying. So that is, when I was preparing the solution, I myself had a thought of whether to do for SQL, and this is like you can consider as an error slide.
Yeah,
but
fine. It is understandable. Yeah.
Yeah, since this has come, anyone has any thoughts on which way would you prefer to go? SQL or
I'd like to take a shot at it. So, like we discussed, we want to keep two different databases for solutions and for problems, right? So, problems is going to have limited set of data, and it is going to be in a way where you just have the problem title, the difficulty, um, the category that it belongs to, whatever, like linked list or stack or whatever, those kind of things. So, in just for the sake of storing problems, we could actually consider a SQL database. And maybe for solutions, we can go for NoSQL.
Yeah, yeah, that's a good reasoning, I think, because problem doesn't have any rows or anything like that, right? It
Yeah,
just-
and solutions are going to be too many as users start attempting those problems. But just for the sake of the problem, it's not going to have too much data, right? At the max, it can have images. Like for graphs and all, we show images, right? So at the max, I think it will be that. So probably for problems, we can think of a SQL database. I mean, I'd like to know what will be the negative of using a SQL database in case anyone has anything.
I feel for user data, like user profile, like how many problems they've solved, what are the credits, or um, uh, for those things we should have an SQL database. It has to be consistent, is what I feel, and there is no need, a special need to go for NoSQL in that case. But given the even the problem might not need an NoSQL. Maybe solution will need, because it is a huge document type, like the programs and everything. Problems are anyway just I think text. So and problems are more read based. Even I think even solutions are read. I don't think the set of solutions that are provided by default are the solutions that are read heavy. But whereas the solutions provided by the user, like user submits the solution, that will be write heavy, right? So I think user definitely has to be SQL, and problem can be SQL. I feel that solution, given its big text, probably solutions can be in NoSQL. That's what I feel.
One thing that I'm thinking is maybe a flexible schema. If we want to add some more attributes to our problem set in future, maybe for example, rating for a problem, like 3 star, 5 star, like that, or anything. So if we anticipate our problem set schema to be changing, in that case, maybe we can go to NoSQL. But otherwise, I don't see. I think yeah, either way should be good. This is one difference, in fact.
There are just a few points I like to add here.
Sure.
Here we are talking about the LeetCode. Okay. Here, eventual consistency also can be acceptable because it is not a transactional based workflow we are following. So we can go with NoSQL also. As you are, for one point loss, you add a no future if you want to add few more attributes to the data, like rating and no. In such cases, NoSQL will suit us more than SQL. That is what my point of view.
So, what are the basic things that we should consider before deciding on SQL or NoSQL? So, one thing is definitely whether we need consistency or not.
Yeah.
The other thing is what is the what is the how with what we are comfortable. The team is comfortable. I think that is also is a the learning curve. I think that is also a huge thing, and also I heard that. I don't know if it is if I'm having the enough knowledge, but replication and then sharding, basically sharding, not replication. The sharding is a little difficult with the SQL database. Is that correct? Because sharding makes the joins really difficult. So when we have to go for sharding, do we go for NoSQL? Please, I mean, if anyone knows the answer, just let me know.
Yeah, when your data is huge and you expect it to grow, and you will eventually do horizontal scaling, then it is better to go for a NoSQL, because scaling will be easy. You can go for like Cassandra or uh, MongoDB kind of database where scaling becomes very easy. If you go for an SQL, as you mentioned, table, foreign key references, joins, that is what is foreign key reference. Joins will be, consume a lot of uh, uh, resources. And also, like, uh, partitioning can be a partitioning the data will be repartitioning can cause a lot of can actually say, for example, you have data from A to K here, L to O here, E to Z here. So tomorrow you decide that okay, there is load here. Then to partition this into another system, it'll be a your queries have to change, and then it'll be a huge rework. So when you know that your data is going to grow a lot, it's better we go for a NoSQL database. That is. Uh, usually that is where NoSQL comes into picture.
Correct,
Yeah.
correct. Yes. As a rule of thumb, recommendation is No, we had this back of envelope calculation. If your data volume is coming in millions of records and the size of the data is in 5 GB plus, right? It's more than 5 GB, then NoSQL should be considered, because you can use SQL also in this case by sharding or partitioning. This is the same thing, but yes, they have other complexities. So the first thing is we calculate the data volume, and based on that we can decide. So if suppose it's coming 20 GB, or then either you can go with 4 shards and have 4 database instances to deal with each of the shard, or you can use NoSQL databases, and NoSQL databases can handle high data volume, and they are designed for read heavy and write heavy systems. So they are good for dealing with high data volume, high transactions. In SQL databases, the only way you optimize the performance is through indexing, and if you have millions of record, the optimization do not happen that fast, and this will become slow and it will become bottleneck until unless you partition it. So that's one important criteria. And then other, Shivam mentioned that consistency is important. Then you can use SQL databases, because SQL databases are designed for transactions and consistency. But yes, in case if that is not required, then you can consider using NoSQL databases. Another aspect is you can use SQL in relational databases. So if you have complex queries and you want to create a lot of queries, then probably you can prefer SQL databases and store relations. In case of NoSQL databases, you have a different way to query. So no, that is another criteria about how many queries you have to run. But yes, NoSQL databases also offer mechanism to query data, but SQL is very standard process and easy to deal with. So for simplicity reason also, sometimes SQL databases are preferred.
So, Tarun, going back to from where we started this discussion, right? Like for the problems database, Tejaswini was in a fix whether we should go for a SQL or go for a NoSQL DB.
Yes.
Specifically in case of problems, right? The use case would be that typically people go and look for problems based on the company, based on the difficulty level.
Yes.
So searching for problems is a basic use case that all users are going to do. So in that case, does SQL gain more brownie points over NoSQL for the problem DB specifically?
Yeah. See, if you have to search for problems, you'll be searching with some of the fields like what is the topic, what is the problem name, title, and description. Here, you may have description and you may want to do keyword based searching also. So,
Yeah.
one suggestion, if I would have to implement it, I would implement it using Elasticsearch, the problem database, because it's kind of a content where I would like to have keyword based searches and maybe fuzzy searches also, where someone has mistyped some spelling. For example, he has, instead of q spelling he mistyped, or graph spelling he mistyped, but still I would like to get the right search, right, results. So I may use here Elasticsearch database, which uses Lucene and Solar as the search engines. And this is a NoSQL kind of database. So that's one preference which I will have. Right, but you may use multiple approaches as well.
Tarun, you're suggesting that all the data, all the problem, the complete problem repository will be in Elasticsearch database?
Just a minute,
Or
hold.
I mean,
Yeah,
okay,
so
no,
the
Elasticsearch we should have a like a backup database, right? And it
correct.
will Elasticsearch would generate a secondary
Yes,
index kind of a thing. Yeah.
descriptions should be stored in the, yes, I would say problems can be stored in the Elasticsearch, but say user data, user profile information, login information about password and all these can be stored in, say, SQL databases. So again, no, there are multiple considerations which may have to do. So based on case by case basis, this could be used. But yes, one option is use Elasticsearch for text-based searching, and problems could be stored in NoSQL database like Elasticsearch.
Yeah, Elasticsearch makes a lot of sense, Tarun. I mean, probably it's the apt database um, for problems. It does basically string search and different regular expression search and everything. I think it really makes sense.
We are actually at the end of the hour. I think 2 more minutes. Uh, I can go further, but I would ask you all if you want me to go further or can take it up in the next session. Mm, We have close to 8 slides to complete. Um, what do we do, Tarun?
Maybe discuss for 5 minutes the high level design, and then we can have a follow-up session for remaining slides, or no, more detailed discussion on the high level design. But I would say just give a glimpse of the component diagram to everyone, so that we get a kind of a trailer of what is going to come in the next session.
Yes. So, yeah, this same thing we'll be discussing for our solution repository. And this is the heart of our problem, that is code execution. Uh, so we'll be discussing about databases, and yeah, this is a high level design. Mm, so for authentication services, what kind of database, problem set, search services. This will be the heart of our problem that we'll be discussing, and mainly we'll be using a messaging queue service to handle code submissions. We have huge number of code submissions. So how do we handle that? We'll be using a message tree which will have like different consumers and workers that will first compile and then run, then validate the actual solution. So we will be discussing in depth. These are very good, corner case scenarios that we'll be discussing about how do we efficiently handle dynamic allocation, how do we support different programming languages, how to handle failed compilation, how to handle so slow compilation of jobs. That is where one of the question was in the beginning. If the system is loaded, how do we handle that test case execution, etc. So yeah, I think it will require a lot of time and depth, and yeah, this is the overview of the system.
Great, Tejashwini. You can present the detailed session in our next class, and yes, we can communicate about the date and time for that. But yes, this was a great session, and this is first time in our forum some woman has presented. So also I appreciate a lot of participation, no, and also especially from Janvi and Natasha also, because yes, we had the Women's Day on 8th of March, so this became
Yeah.
great Women's Day edition of System Design. So thanks a lot, and it was wonderful session. And no, thanks for taking this initiative. But yeah, we didn't plan. I didn't plan that. Okay, we'll have some Women Day, but just it's like coincident, which is good. So great. So nice session, and definitely looking forward for more detailed discussion. And we'll share the presentation to others, and I'll also share the recording and notes.
Sure.
Thank
I
you,
think not
Tarun.
for me. And very interactive session. Thank you, Tarun, for giving this opportunity. I
Thanks,
enjoyed.
Thanks, Tejaswini, for the detailed
Thank you, Tejaswini, for the
Hoping
great.
the next session also.
Thank you.
Thanks.
Thanks, Tarun.
Thank you, Tejaswini.
Awesome.
Thank you. Bye-bye.
Bye.
Great. Bye.